Okay, sometimes they can give you a binomial expansion where you have two x variables inside the bracket. Notice how they have different powers. You would never be asked 3x plus 2x to the 10 because this would just be 5x and it wouldn't be a binomial expansion. So you will have different powers if you had two x variables inside the bracket. Now this question isn't asking us to expand everything, but it is asking us to find x to the 18. So first thing we're going to write down is we're going to do n choose r, a to the n minus r, b to the r. And then let's fill in the information we have. We know that n is 10. So n here is 10. Okay. And we know that this one is a and this one is b. So I'm just going to write this down underneath so I can keep the rest of our formula there. So we have 3x to a power and 2x squared to a power. And I know these powers link here, so I can use the formula both to help me. Now, my main focus is going to be r here for here. Okay? Now, we also know, just a side note, that these two always add to make n. So they're going to add to make 10. So we know those two numbers are going to add to make 10. However, over here, the 2 is going to affect this one because we would end up multiplying these two together because they're powers. So if, for example, we tried a number and we tried to use 5 and 5, and right now you're just going to focus on the x variable. Okay, so yes, we would use 3 to the 5 and 2 to the 5, but let's just pause for a second. This x would become x to the 5. This x would become x to the 10 because it's 2 times 5. And then we think, okay, well, when I multiply these, because I'm multiplying everything together, like that. When I multiply them together, I'm only going to get x to the 15. Okay, so that tells me this one needs to be a bit bigger because I need to make it larger. And the only way I can make it larger is because I'm multiplying by 2. So let's try a different number, or let's use a little bit more logic with this question. So if we have something, yeah, here we have this one, and we're going to times it, and we have one here. But when we have the powers, when we're multiplying x's, yeah, we actually add the powers. So it's going to be something plus 2 lots of something will equal 18. That's what we need for our powers because it's going to be x to the something, x to the something, x to the 18. That's what we're looking for. So we're trying to find two different numbers now that would still add to make 10, but would work to make 18. Then you can try different ones. Okay, I know my 5 needs to be bigger. If I have a 6 here and a 4 here, okay, well, I get 12 plus 4, that's 16. Okay, that's not quite big enough. What if I have a 7? 7 and 3. So I have 14 plus 3, or 17. Okay, looks like it might be the next one. So if we had 8 and 2, this would give us 16, because it's 2 times 8, and this will give us 2. So 16 plus 2 gives us 18. That's what we want. So now we go back to our question and we go, okay, this needs to be 8, and this needs to be 2. That tells us now that r is 8. So we're just going to pull now all the relevant information, and we have 10, choose 8, and then we've got 3x squared times 2x squared to the 8. And then the next step would become our 10 factorial, 8 factorial times 10 minus 8, so 2 factorial. And then we've got to times it by 9 x squared, because you do this bit squared also. And then you're going to times it by 2 to the 8, which you can probably grab a calculator for. It's like 64, and then double that is 128, double that is 256. It's going to be 256. 8x to the 16. Okay, now let's see how the numbers go. This might have been on a calculator paper as well. So over here with the factorial, we have 10 times 9 times 8 and so on. But hopefully your knowledge of factorials shows that you can do 8 cancelling and 8 factorial. These two are both 8 factorial, so we can cancel them. So that's going to become 90 divided by 2 times 1, which is just 90 divided by 2, which is going to be 45. So then we bring the last bit down, and it's going to be 45 times 9x squared times the 256x to the 16. And then, yeah, you can just grab a calculator and do this bit. Times together, which I will do, so I finish the question. 45 times 9 times 256 is 103,680 x to the 18. Double check my calculations on a calculator, feel free, but that is the main bit up here, how you get this section here.